Okay, we'll study about the refraction of light. We did the problem also, no? One problem is solved. Solved. Okay. We'll study about the refraction of light. Write down this. Refraction of light through a prism. Prism. So in the prism, what happens whenever there is a refraction, we can see dispersion of the white light, correct? So we can see dispersion of the white light through a glass prism. So dispersion of the white light, why it happens? That is, what is dispersion of the white light?
It's splitting into 7 colors.
It's splitting into 7 colors. We call it as the dispersion of the white light. So white color is made up of 7 colors. Combining all, we will get the white color. So in the while there is a refraction in the prism, we see the dispersion effect. That means the white color will split into different colors. So why it is possible? Because different colors will have different wavelength. Okay, different colors will have different wavelength. Okay, so in the prism, what happens? They will split into different colors. So because they have different wavelengths, okay, because they have different wavelengths, they bend due to refraction with different angles. That is why they split. Okay, so first thing, white color has 7 colors. It has the 7 colors which is in the rainbow. If you mix everything, you will get the white color. So each color will have different wavelength of light. Each color will have different wavelength. Okay, while there is a refraction through a prism. Refraction means what? Light is going from one medium to other medium. It bends. So here it is going from air to glass, correct? Now air to glass it is going, then from glass it comes out to the air. Okay, so there is a refraction there. So in this, when light is passing through some other medium other than air or vacuum, what happens? They will bend. Okay, when they bend, what happens? The each wavelength or different wavelength light will bend in different angles. Different wavelength lights will bend in different angles. That is why we will be able to see them separate. That is, red light bends in a different angle, whereas a violet or blue bends in a different angle. How much it will bend, it depends on the wavelength of the light. Okay, it depends on the wavelength of the light. If wavelength is more, so that bending we call it as the deviation. So how much will be the deviation, whether it is more or less? If wavelength is more, becomes less. When wavelength is more, deviation is less. That is, red light bends less. Okay, blue light or the violet light bends the most. Violet and blue, it looks almost the same there. That's why they say blue also they say, but violet is at the end. Okay, so violet light or the blue light, they bends the most. Red light bends the least because the wavelength of the red light is more, whereas the violet and blue it is less. Okay, that is the reason. So refraction of light through a prism. In that, what are we? Light, right down, light travels. Okay, light travels light travels from air to glass and from glass to air. Okay, hence there is a refraction. There is a refraction of light in prism. in prism. Okay, next, right? Angle of deviation. Angle of deviation. Okay. It is the angle. It is the angle at which emergent ray and the incident ray, or it is angle at which emergent ray and emergent ray makes with the incident ray, like that. Emergent ray makes with the incident ray, or angle between emergent ray and incident ray. Anyway, you get it. Okay. So here, write down this angle D is equal to, okay, angle D is equal to, you will get angle I plus angle E minus angle E. Huh. This will be this function written. Now, this is angle of prism. Angle of prism. I'll explain. See, second. Inside. Write down this. Written. First thing, angle of deviation. Angle of deviation, it is the angle between the incident ray and the emergent ray. Angle of deviation means it is the angle between the incident ray and the emergent ray. See, first you consider a prism. In the prism, what happens? First, light from air to, in the prism, light goes from air to glass, then from glass to air. From air to glass, then glass to air, correct? So in this case, what happens? Angle of incident is, this is the angle of incident, okay? So the light which comes out of the prism, we call it as the emergent ray. So the angle between the incident ray and the emergent ray is called as angle of deviation. Again, I repeat, see, in a prism, light goes from air to prism, that is glass, then from glass to air, okay? The light going from air to prism, that call it as angle of incident, and the light which is coming out, the light which is coming out of the prism, we call it as angle of emergent, okay? The ray which is coming out, we call it as angle of, ray of emergent, okay, or emergent ray. Now, the angle between the incident ray and the emergent ray, that we call it as angle of deviation. That is, if the prism was there, not there, then what happens? It would have gone straight. But now, it tends to bend. So, how much that bend is there due to the prism, that we call it as angle of deviation.
We just reduce the incident ray
And emergent ray.
normal part. And the way I
See, no, this is angle of incident, this is angle of emergent.
the action only.
Just because this light only will bend and it will go like this, no? So if you extend this emergent ray and the incident ray, The what is the angle between them? That we call it as angle of deviation. That will be equal to, if you calculate, how much you will get? What is that? That I know. I was not knowing first time. Okay, okay. Write about dispersion of white light. Dispersion. After, what happened? Where you want to keep that? Okay, don't discuss about that. Now we'll study dispersion of white light. White light by a glass prism. Okay. Hmm. Write down this, the phenomenon of splitting of white light into its constituent colors when it passes through a prism. Is called dispersion. It is called dispersion.
Prism.
Huh. The band of colors obtained are with color. That is violet. Write down this: violet, indigo, blue, green, yellow, orange, and red. Next, cause of dispersion. A red light has maximum wavelength. It has maximum wavelength, and violet light has minimum wavelength. Right. So dispersion, it is the phenomenon of splitting of white color into constituent colors. That is, white color is made up of 7 colors. It is mixed, then it becomes a white color. Now, in this phenomenon, it will split, that white color will split into its colors, constituent colors. So this phenomenon, we call it as dispersion of white light. Okay. So when we can see dispersion of the white light, when white light or the sunlight is passed through the prism, we can see the dispersion. Okay, we can see the dispersion of the light. So, what is the reason for this dispersion? See, the white color has 7 colors, correct? In that, each color will have different wavelength. Each color will have different wavelength. Red has the maximum wavelength and it keeps on reducing. Violet will have the least wavelength. So, in the air or vacuum, though all the colors will have the same velocities, they will travel with the same velocities, even though they are having different wavelength, they will travel with the same velocity. Again, I repeat, see these things. White light has the 7 colors. These 7 colors will have different wavelengths. But when they are traveling in air or vacuum, they will have the same velocity so that they will not deviate. That is, they will not bend in different angles. But when they travel in any other medium, okay, in any other medium, then the one which is having different wavelengths, okay, they will have different velocities. That is, they will bend in different angles. So when they bend in different angles, you can clearly see them. Okay, when they bend in different angles, you can clearly see them. And wavelength is inversely proportional to deviation. Wavelength is inversely proportional to the deviation of the angle. That's why red light will have least deviation, whereas the violet light will have the maximum deviation. Okay, red light will have the least deviation, whereas the violet light will have the maximum deviation. All say from the red light, what and all colors we see? First, we see red light. Then comes the orange, yellow, green, blue, indigo, violet. By seeing it first, it starts like that, right? From red to orange, wavelength will reduce. Like that, it keeps on reducing. Violet will have the minimum wavelength. So red deviates least. Violet deviates most. Hence, it will split and we can easily see the colors. So, on deviation, how it is dependent? Incident ray, the angle of incidence, then the emergent ray. That difference only we call it as a deviation. Correct? That difference we call it as a deviation, and that will be equal to I plus E minus A. I plus E minus A. Okay, that will be equal to angle of deviation. That's why we can see only in the prism, not like anywhere that splitting will be there, little bit will be there, but that variation you can't see. But we can see in the prism because of this angle, how much it is there. Depending on that, the deviation will be there. No, minus the angle, right? So if angle is less, deviation is more. We can see that clearly. That's why in the prism we can see it clearly. Understood now? So wavelength of red is more maximum and the wavelength of the violet is the minimum. So deviation will be least for the maximum wavelength. For red it is least. For violet deviation is more. So there, since the deviation is there, we can see the different colors. So this phenomenon we call it as dispersion of the white light. So cause of dispersion, how much we got?
Ma'am, the minimum wavelength.
What was minimum wavelength? Okay. Light rays of different wavelength. Write down this. Light rays of different wavelength. Okay, light rays of different wavelength travel with same speed. Travel with same speed in vacuum and air. But in any other medium, medium, they travel with different speeds. They travel with different speeds and bend through and bend through different angles and bend through different angles which leads to the dispersion of light. A red light travels faster, hence deviates least, while violet light travels slowest, hence deviates most. Okay, so wavelength is directly proportional to inversely proportional to deviation, or directly proportional to 1 by deviation, or wavelength is inversely proportional to deviation. And also, if you observe here, red light travels faster. In air or vacuum, light travels very fast, correct? When compared to any other medium. So, if any other medium it is going, in that red light travels faster. So, the change in velocity is less, correct? When change in velocity is less, that difference is less, then deviation is less, that we studied in during refraction. Do you people remember? We can connect each other things. Refraction, how much it will bend depend on the difference in velocities, correct? So red light travels faster. So in air or vacuum, anyway it is traveling faster. If red light is faster, the difference in velocity is less. So bending will be less. That's what here also we see. So we can connect each other things like that. So in violet, what happens? Wavelength is less and it travels slower. So that change in velocity is more. So deviation will be more. That is bending will be more. Okay. There also we can connect. If you are very clear about the concepts, one to the other, you can clearly connect that things. Okay. Not only that, see, red light has wavelength is more, no?
That's why many parts you see red.
Because scattering will be less there. Scattering will be less. So you can see red light from far distance also you can see. That is the reason.
Yes, right. So when I prism and then it becomes same like
The second prism will be inverted. So the light will first get dispersed, then it get recombined, and it will go and then recombined. And this is the common reason.
it's so neutral is so job. That's why
Okay, recombination of white light. In recombination of white light, first white light is split into 7 colors, then it is again passed on to the next prism. We can see the recombination of the white light. Okay, that is again these 7 colors will combine to form the white light. So from this, what we were able to know is white color is made up of 7 colors. Okay, so first one, the prism, we will keep it erect. Still not finished, Lakshit, talking? Huh? See, you people should have some sense of responsibility, no? It's not like I am scolding. You should have that responsibility. Okay. So recombination of white light. One white light, when you keep it in front of a prism or an erect prism, so when light is passed through this prism, it will split into 7 colors. Now these 7 colors are passed through the inverted prism. then what happens? They will combine to form the white color. So here we can know that white color is made up of 7 colors. Okay, one will be the erect prism, the other will be the inverted prism. Okay? And they are kept very nearby to that, so that all the colors will pass through it. Okay, so there we can see the recombination of the white color. Okay, write down this. And in these questions, you have to write the diagram. Okay, in these questions, you have to write the diagram. Band of colors, no, that only we call it a spectrum. Huh. So red, this is violet. Red, violet. A, B, C. On the screen, we get the white color. That slit is passed so that white light, monochromatic light will go through that. That means the white light, when it is passed through the slit means small hole. When it is passed through it, it focuses on the prism. Oh, that's it. That is used. That's all. Okay, it's just slit means small hole through which light is passed. Write down. Two prisms. Write down this. Two prisms are kept close to each other. Close to each other. One is erect. One is erect position. And the other is in an inverted position. Is in an inverted position. The light gets dispersed. The light get dispersed when passed through the first prism. Through the first prism. These things are easy to score. Okay, this chapter also. The second prism receives all the 7 colors, all the 7 colored rays, from the first prism. And recombines them into original white light. Okay, so here why we keep it inverted only and why it will recombine, can you tell me?
Because when light passes from white light passes. It disperses when it goes to another prism. The violet light bends more, red light bends
less. So they can combine. Correct. Good. Very good.
Produce into one.
One light. See here, red light deviates least, violet light deviates most. Now, red light again it will deviate less. The angle here will be less. Here, the violet will deviate the most. So, bending here will be more. So, all together it will combine and it will get. The total angle will become 0. Then it will combine and it will go.
Yes.
Okay. Next is about the rainbow. So in the rainbow, there is something called total internal reflection. Very important concept. Total internal reflection. This is clear, no? Next we'll study about rainbow. Now tell me about total in the rainbow. There is the dispersion of the light. Okay, and also there is total internal reflection. So total internal reflection is another phenomenon what we see. Okay, so when light, okay, incident ray, when it is there is a refraction, basically it is going from one medium to the other medium, and if there is the incident ray angle is less than the critical angle, there is some angle called critical angle. If the angle of incidence is less than the critical angle, then there will be total internal reflection. That means light will reflect inside that only, inside that medium only. Then comes the refraction here. Again, I repeat, see, in a rainbow, there is one is the dispersion of the light. Another concept what we have here is total internal reflection. So when total internal reflection happens, when incident angle, the angle of incidence is less than something called critical angle is there. If the angle of incidence is less than that critical angle, there will be the phenomenon called as total internal reflection. Okay, and this phenomenon only they use for optical fibers. Nowadays we use optical fibers, no, for internet and all. Correct. So they use this total internal reflection only. Earlier they used to use the copper cables for the internet. Now they are using optical fiber. Can you tell me any reason, Bhavi or someone? Keisha? Earlier, they used to use copper cables, okay, for the internet. Then everything they changed to optical fiber. For that, too much of money they would have spent. Simply, they would have not done, right? Why they are doing now? Instead of electrical cables, now they use optical fibers. You would have heard about optical fibers. No. But to change, they would have spent a lot of money. Why they are using it? No, it is not cheaper. It is more. Yeah, I will tell. Wait.
I mean, it's faster.
Faster in it. See, in the cable, okay, in the copper cable, the how much fast it can travel. Okay, because now we need high speed internet and all. So there was a limitation for that. It can't go more speed. It was not able to go in a higher speed because when at that time when copper cables were there, to send one small data also it used to take a lot of time. But now we can upload full movie in a very fast time, right? What is the reason? Because copper cables there is a limitation. After that, it can't go like it can't be very speed. Transmission was not possible through that. Okay, but through optical fiber, light can be passed. The signals can be passed very fast. That is why they use the optical fiber. Optical fiber means the signal is passed as a light. fiber, it is a fiber material. Where why it is called optical fiber? Because signal is passed like a light inside that. Okay, so this light, how it will travel? See, one fiber, it looks like this. Some fiber is there, means light will travel like this. At the end of the cable, it comes out. Okay, so light is traveling like this inside that. So here, what happens inside this? From here, there is refraction. Okay, then after entering that, there is internal reflection. Okay, why there will be internal reflection means if the incident ray angle of incidence is less than some angle called critical angle, then there will be total internal reflection. Light should can pass through like this, no? It will not go, but it will be internal reflection only. What is the reason? If the angle of incidence is less than the critical angle, there will be something called total internal reflection. That is, light will be reflected inside only. Okay, that phenomenon we call it as total internal reflection. So that only they use for optical fiber also to go light. It will not escape outside. Inside the fiber only it will travel. Afterwards it comes out. Okay, so this phenomenon only we see in the rainbow also. That is rainbow. How it is formed? It is dispersion of light in a dew or a drop of water, droplets, right? So there first it will be total internal reflection, then comes the dispersion of light by reflection. Okay. So this we call it as the total internal reflection. Very important phenomenon. Because of this phenomenon only we see the optical fibers. Because of that only now we have so much high speed cables. Okay, high speed internet, why we see? Because of this optical fiber. That's why they change everything from the copper cables to optical fiber so that the speed of the internet will be very fast. Light can travel very fast, right? Huh? And here transmission loss is less. That is, when it is moving, loss is less. But in copper cables, if it is traveling very fast, the loss of energy was very much high, and after one speed, it can't go beyond some speed. That was the limitation. Okay. There also we see all these physics phenomenon. By that only they have made so much of technology is made by using these itself. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.